Welcome. I'm going to keep going on the Quantum and the Lotus because I love this book so much. We were at chapter 3, I believe. Yep. Right. Okay, chapter 3, In Search of the Great Watchmaker. Is there a principle of organization? When we consider the remarkable harmony and precision of the universe, it is tempting to imagine that there is an all-knowing creator, from the secular view, some sort of principle of creation that finally adjusted the evolution of the universe. The omnipotence of such a creator would explain everything, and there would be no need for us to wonder about the origins of our astonishingly complex universe, or about how life arose, or how inanimate matter can be compatible with animate matter of life. The question of whether or not there is a creating God is a key point of distinction between the world's great spiritual traditions. For Buddhism, the notion of first cause does not stand up to analysis. Some scientists also dismiss the need for a God, arguing that the exceptional fine-tuning of the universe arose by chance. Others, however, believe that there is some kind of an organizing principle at work in our world. Can this notion of such a principle stand up to analysis? Is it necessary and logical? Swan, actually first. But first, coffee. Cold coffee, okay. Swan. Since the 16th century, the place of humanity in the universe has gotten smaller and smaller. In 1543, Nicholas Copernicus, a Polish priest, knocked the Earth off its pedestal as the center of the universe and discovered that it was just another planet revolving around the sun. Ever since, the ghost of Copernicus has continued to haunt us. If our planet wasn't at the center of the universe, then, our ancestors thought, the sun must be. But along came an American astronomer, Harlow Shapley, who discovered that our sun is just a suburban star among hundreds of billions of stars that make up our galaxy. We now know that the Milky Way is only one of the 100 billion or so galaxies in the observable universe, which has a radius of about 15 billion light years. Humanity has a grain of sand on this vast cosmic beach. Oh, humanity is just a grain of sand on this vast cosmic beach. Human life has become smaller in terms of time. Now we know that on a timeline that shows the 15 billion years of the universe as 1 year, the first human only appears at 10:30 p.m. on December 31st, about 3 million years ago. I am not here to have a discussion about evolution or anything like that. Just throwing that out there now. Okay, humans showed up 3 million years ago at about 10:30 p.m. Stonehenge is built and the Egyptian civilization arises at 11:50 and 54 seconds p.m., about 3,000 years ago. The Buddha appears on the timeline at 11:59:55, 2,500 years ago. And Christ shows up at 11:59:56, 2,000 years ago. The European Renaissance occurs at 11:59:59, 450 years ago, on the last day of the year. The shrinking of our place in the world led to Pascal's cry of despair in the 17th century. The eternal silence of the endless space terrifies me. Pascal's words were echoed 3 centuries later by the French biologist Jacques Monod. Man knows at last that he is alone in the unfeeling immensity of the universe, out of which he has emerged only by chance. And the American physicist Steven Weinberg remarked, "The more the universe seems comprehensible, the more it seems so pointless." Personally, I don't think that human life emerged purely by chance in an unfeeling universe. To my mind, the universe is so large that it evolved that way in order to allow us to be here, which is a nice thought. Matthew. Careful, that sounds like what Bernardine de Saint-Pierre said, "Pumpkins have slices because they're made for family eating." Swan. We must indeed be careful about the arguments based on justifications of final causes. Science itself is born from a total and categorical rejection of any such technological thinking, which is the province of religious doctrines. That said, modern cosmology has discovered that the conditions that allow for human life seem to be coded into the properties of each atom, star, and galaxy in our universe, and in all of the physical laws that govern it. The way our universe evolved depended on what are called initial conditions, and on about 15 numbers called physical constants. Newton's laws of gravity depend on one of these constants, a number called the gravitational constant, which determines the strength of gravity's attraction. In the same way, there are 3 other numbers that control the power of the strong and weak nuclear forces and the electromagnetic force. Then we have the speed of light and the Planck constant, which fixes the size of atoms. After that, there are numbers that describe the mass of elementary particles, such as the proton, the electron, and so on. These constants play a fundamental role in how a universe evolves. They determine not only the mass and size of the galaxies, the stars, and the Earth, but also of living beings, the height of trees, the shape of a rose petal, and the weight and size of ants, giraffes, and people. The reality we know would be quite different if the constants changed. As the name suggests, these constants do not vary in time or space. This has been checked by careful observation of far-off galaxies. As for the initial conditions of the universe, they concern, among other things, the amount of matter it contains and its initial expansion rate. If these constants and initial conditions were just slightly different, then we wouldn't be talking about them. The universe, right from the start, seems to have carried the seed that allowed for the emergence of consciousness of an observer. In the words of the physicist Freeman Dyson, the universe, in some sense, must have known that we were coming. The fact that our existence seems to be coded into each part of the universe just shows how compatible we are with the physical world. But it certainly doesn't mean that you can say this is true because there was some intention that we should be here. Swan. Yes, but so far we haven't come up with a theory that explains why one of these constants were fixed at a particular value and not a different one. We've been handed these numbers on a plate and have to accept them. Matthew. Is there really no explanation for this? Swan. Leaving aside pure chance, which we shall come back to later, there is the superstring theory, which states that the elementary particles are created by the vibrations of infinitely teeny bits of string. According to the theory, the mass and charge of a particle are determined by how these strings vibrate. But this doesn't really solve the problem, because the theory doesn't explain why the strings vibrate one way and not another, or why they create particles with exactly the properties needed. Matthew. Could these physical constraints be in a different universe? Swan. According to our present state of knowledge, there is no reason why they shouldn't vary from one universe to another. By constructing a large number of model universes on their computers, astrophysicists have discovered that if the physical constants in the initial conditions were just slightly different, then there'd be no life in the universe. How much would they have to change by? Swan. The exact figure depends on the constant and which initial conditions we're talking about. But in each case, just a teeny change would make the universe barren. For instance, let's take the initial density of the matter in the universe. Matter has a gravitational pull that counteracts the force of expansion from the Big Bang and slows down the universe's rate of expansion. If the initial density had been too high, then the universe would have collapsed into itself after some relatively short time, 1,000,000 years, a century, or even just a year, depending on the exact density. Such a time span would have been too short for the nuclear alchemy of the stars to produce heavy elements like carbon, which are essential to life. On the other hand, if the initial density of matter had been too low, then there would not have been enough gravity for stars to form. And no stars, no heavy elements, and so no life. everything hangs on this extremely delicate balance. To give you an idea of just what small changes I mean, consider the density of the universe to start or at the start or at Planck time. If it had to be fixed with an accuracy of around 10 to the negative 60, that is to say, if one figure after 60 zeros had been different, the universe would be barren. There would be no life, no consciousness, and no you and no me to discuss it. This astonishing precision is analogous to the dexterity of an archer hitting a 1 centimeter square target placed 15 billion light years away at the other side of the observable universe. In the face of such extraordinary fine-tuning, many cosmologists have argued that the universe was so finely tuned in order to allow it to produce life, consciousness, and finally an intelligent observer capable of appreciating its beauty and harmony. This idea is called the Anthropic Principle, from the Greek anthropos, meaning person, which, anthropology. I think we could have figured that one out. According to this view, humanity has gained pride of place in the world once more, not as the center of the universe, but by being the very reason the universe was designed as it is. This is a strong version of the Anthropic Principle. There is also a weak version that doesn't presuppose any intention in the design of nature. It almost comes down to a tautology. The properties of the universe must be compatible with the existence of humankind. The term anthropic is really inappropriate because it implies that humanity in particular was the goal toward which the universe has evolved. But the arguments I've just presented can be applied to any form of intelligence in the universe. I like that. We're not necessarily the most important things in the entire fucking universe. Whichever of these versions of the principle one prefers, modern cosmology has, in this anthropic way of thinking, rediscovered the notion of a close link between humankind and the universe. Paul Claudel's message of hope answered Pascal's cry of despair and expressed this new delight with the world. The silence of endless space no longer terrifies me. I walk through it with familiar ease. We do not live in some isolated part of a wild and hostile desert. Everything in the world is fraternal and familiar. Matthew, as far as Buddhism is concerned, the idea that there is some principle of organization that is supposed to have tuned the universe perfectly so that the conscious mind could evolve is fundamentally misguided. The apparently amazing fine-tuning is explained simply by the fact that the physical constants in consciousness have always coexisted in a universe that has no beginning and no end. I don't mean that the universe is static. Rather, I mean that what seems to be the start of the universe, the Big Bang, for instance, is just one episode in an unbroken process. The conditions of our present universe harmonize with those of the previous and subsequent ones, because the process of causality is unbroken and entails a compatibility between the nature and cause of that, and that of the effect. The universe has not been adjusted by a great watchmaker so that consciousness can exist. The universe and consciousness have always coexisted and cannot exclude from each other. To coexist, phenomena must be mutually suitable. The problem with the Anthropic Principle, or any other teleological theory, is that it puts constants before consciousness and thus claims that the constants exist only so that they can create consciousness. The Anthropic Principle comes down to picking up two halves of a walnut and saying, "It's incredible. It looks like these two pieces have been designed to fit perfectly together." Swan. I can certainly see that Buddhism has no need of an Anthropic Principle to explain life and the conscious mind, but let's suppose that Buddhist view is invalid. Let's suppose that the Buddhist view is invalid, and that it is, after all, necessary to explain the fine-tuning of the physical constants and the initial conditions of the universe. We might then wonder if this tuning was the consequence of chance or necessity, to quote Monod's book. If we do not want to accept the Anthropic Principle, the argument from necessity, then we would have to turn to the other main argument cosmologists use to explain the fine-tuning, the chance hypothesis. This hypothesis postulates an infinite number of other universes, and that each of these universes is constructed according to one out of all the possible combinations of physical constants and initial conditions. Thus, for each combination of constants and initial conditions, a universe has once existed. But ours was the only universe born with just the right combination to have evolved to create life. All the others were losers, and only ours is the winner. If you play the lottery an infinite number of times, then you inevitably end up winning the jackpot. Matthew, when you say other universes, do you mean parallel ones? Fun, that's one possibility. The idea of parallel universes is certainly one of the strangest notions in physics. The idea depends upon one of the fundamental and quite strange findings of quantum mechanics. According to quantum theory, it is impossible to state precisely where subatomic particles are located. We can only calculate the probability of finding an electron here or there. We cannot determine precisely its trajectory in the way that we can determine the orbit of a planet around the sun. This lack of precise location is what's called quantum fuzziness and leads to a discomfortingly strange probabilistic description of the world. According to such a description, any given electron might be here, there, or anywhere all at once. In order to find a way around this and to revert to the more comforting realist view, where any given electron has only one position, the American physicist Hugh Everett came up with a radical idea. He proposed that the universe divides into as many nearly identical copies of itself as there are possibilities for the position of that electron. Instead of the electron being here, there, and everywhere in a single probabilistic universe, there would be one universe in which the electron would be here, another universe in which it would be there, yet a third universe where it would be in another position, and so on. Through this continual process of division, a vast range of universes would be born. Some of those universes would evolve to be very similar to ours, maybe even differing only by the position of one electron in one atom. Others would differ more. There would be one in which you had gone for a stroll instead of sitting here talking to me. Other universes would exist in which Tibet hadn't been invaded by China, and in which men hadn't walked on the moon. Others still would be more radically different from ours. Their physical constants, initial conditions, and physical laws wouldn't be the same. Each time the universe divided, all living beings would also be divided, you and I included. The parallel universe created what would be isolated. The parallel universes created would be isolated from one another. No communication between them would be possible. Matthew, when it comes to conscious beings, would this mean our consciousness would be splitting in two at every single instant? The notion of an individual stream of consciousness would become meaningless? Swan, that's an interesting argument against parallel universes. Personally, I find the idea that the universe divides into multiple universes in this way decidedly odd. It's not at all clear to me that our bodies and our minds could divide in such a way without our noticing. Buddhism considers that there is a plurality of worlds, or of states of being, but it doesn't agree that there could be totally disconnected parallel universes living separate lives. Such an idea would run against the idea of the global interdependence of all phenomena. What we can possibly be outside the infinite number of phenomena have been linked together for all time and shall remain linked forever. Ended with a question mark. What can possibly be outside the infinite number of phenomena that have been linked together for all time and shall remain linked forever? Question mark. If phenomena exist only in terms of interdependence, then we cannot separate them without causing them to disappear. Separately existing universes can't cohabit in such a global infinity. Another problem with this hypothesis is that if you play the scenario out, you can see that an infinity of universes is created, and with this infinity, all possible universes must exist, including ones in which totally contradictory conditions are true, or in which opposite events happen. But in global interdependence, mutually exclusive phenomena cannot coexist. Additionally, if at any moment there were as many universes being created as there are particles in the universe, since these particles constantly change states, and so each new state would lead to at least 2 universes. Such a process would destroy all idea of causality, for the same causes and the same initial conditions could simultaneously lead to opposite results. I'm getting briefly confused in what I'm even reading at this point, but they're saying that string theory is difficult because the idea that you would have infinite number of universes that would then contradict one another is a very difficult thing to wrap your head around. So maybe it not being the most simple explanation might not be what's actually happening. Fun. That's exactly what this interpretation of quantum mechanics argues. The existence of parallel universes is dependent on what we call true chance. That is to say, the absence of causality. In a world of parallel universes, the idea of moral responsibility becomes meaningless. This scenario argues that all possible outcomes of events must happen, each in its own universe. Therefore, a criminal could plausibly argue that he should not be held accountable for his crime because this is the universe that just happened to be the one in which, by chance, he perpetrated. In addition, he could argue that there were many other versions of himself in other universes who didn't commit crimes. Matthew, but if phenomena can exist without any cause, anything can result from anything. However, if phenomena are governed by global interdependence, then the world does not allow for such pure chance, and freedom itself can only be expressed through the laws of cause and effect. Swan, I agree that the idea of parallel universes is implausible. But there is another way of thinking about multiple universes. We've already discussed the notion of cyclical universes, which would not be parallel in time, but successive. Whenever the universe was reborn from its ashes, it would start all over again with a new combination of physical constants and initial conditions. Almost all of these cycles would produce barren universes, incompatible with the appearance of life and consciousness. Then, from time to time, a universe like ours would crop up with a winning combination. The big problem with this idea is that, for the moment, astronomical observations seem to show that the universe doesn't contain enough matter for gravity to reverse the outward motion of the galaxies and pull them into a big crunch, which is necessary in order to kick off a new cycle of growth. According to our present state of knowledge, this expansion will be eternal. Physicists are an imaginative lot. However, they have come up with a scenario whereby a new Big Bang would not require a preceding Big Crunch. The American physicist Lee Smolin has proposed the idea that a new universe could spring out of the midst of a black hole in a fantastic explosion just like our Big Bang, thus creating a new arena of time and space. Conditions at the time of the Big Bang and at the center of a black hole are similar because they are both characterized by extreme densities. The universe created in this way would be totally disconnected from ours because no information could pass through the center of a black hole and so reach our universe. So far, this scenario has no experimental backing and is more like science fiction than science. Matthew, this new universe might be disconnected in terms of transmission of information from one to the other, but not in terms of causality, given that the black hole came from our universe. There would thus be a certain continuity between the two universes. Swan. There is one other interesting version of the multiple universe idea. A Russian physicist, Andrei Lind, has proposed a theory whereby each of the infinite number of fluctuations of the primordial quantum foam created a universe. Our universe would then be just a teeny bubble in a super universe made up of an infinite number of other bubbles. None of these other universes would have intelligent life because their physical constants and initial conditions wouldn't be suitable. Intriguing as all of these notions are, I personally find the idea of multiple universes, parallel or otherwise, hard to swallow. The fact that all of these universes would be unobservable and thus unverifiable contradicts my view of science. Science rapidly becomes bogged down in the metaphysics if it is not subjected to the test of experimental proof, which I imagine is hard at the quantum and astrophysicist level. Matthew. All the same, metaphysical preferences are constantly being used in scientific work. When several mutually exclusive hypotheses turn out to be equally good explanations for experimental evidence, then physicists are often influenced by metaphysical considerations when deciding which one to adopt. Declaring, for instance, that anything that is unobservable by physical means is non-existent is a metaphysical point of view. Such inexistence lacks any proof. In the end, it's possible to eliminate metaphysics when dealing with our origins. No matter what science may discover about the Big Bang, the pre-Big Bang, or any other type of beginning for the universe, only metaphysics can ask, was there ever even a beginning? Or else, why should there be a beginning? This is the opinion of some scientists. Francois Jacob wrote, "One must be totally excluded from scientific investigation. This is the origin of the world, the meaning of the human condition and human life's destiny. Not only are these futile questions, each of us asks them at some time or another, but these matters, which Karl Popper called ultimate, concern religion, metaphysics, or even poetry." Swan. Okay, I agree that my position is a metaphysical one, and yet it's always been observation that has ultimately decided the fate of scientific theories. For example, Einstein's theory of gravity has replaced Newton's because relativity can explain phenomena that escape Newton. No matter how beautiful and harmonious the theory of relativity might be, it would not have been accepted without experimental demonstration. This position is, in a way, my version of Pascal's wager. Pascal's wager is also partly inspired by a principle of economy called Occam's razor, after the 14th century theologian and philosopher William of Ockham. The idea is to cut out all the hypotheses that are unnecessary when it comes to explaining a situation and go for a simple answer, since it's more likely to be right than a complicated one. So why create an infinite number of barren universes just to have one that is conscious of its own existence? Matthew, are you implying that the Creator did not have to produce a whole batch of failures for the purpose of coming up with the right universe which contains us? This once again presupposes that there was a purpose in the creation of life and consciousness. But who is this Creator? Where did he come from? From a creator of creators? If not, then he must be his own cause. An effect or a result cannot be its own cause. Swan. Another factor that sets me against the chance hypothesis is that I can't imagine that the world's profound beauty and harmony could have been produced at random. Our universe is beautiful. Glowing red sunsets, the delicate outline of a rose petal, the wonderful pictures of stellar nurseries, or the elegance of a galaxy's spiral arms touch our very souls. The universe is harmonious because the laws that govern it don't vary either in time or in space. All right, keep going. Matthew. The beauty argument also fails to stand up. Beauty is purely relative. A rose petal is a thing of beauty to a poet, food to an insect, and absolutely nothing to a whale. Spiral galaxies weren't beautiful to anyone until a small minority of people had the chance to examine them in the 20th century. If the universe had been adjusted so that an observer capable of appreciating its beauty and harmony would appear, then it would be just enough to have a scattering of intelligent observers here and there in the universe. What would be the point of having beautiful uninhabited or uninhabitable planets, as well as galaxies that no one will ever see? Swan. I grant you that at first sight, such an argument seems itself to go against Occam's razor. But in principle, all of those planets and galaxies could one day be observed by us or by an extraterrestrial intelligence. I also have one more argument for my wager against chance. There is a profound unity in the universe. As physics progress, it has unified phenomena that we used to think were totally distinct. In the 17th century, Newton unified heaven and earth. The same gravitational force makes an apple fall in an orchard or the moon orbit around the Earth. In the 19th century, Maxwell showed that electricity and magnetism were just two different aspects of the same phenomena. He then realized that electromagnetic waves were light waves, thus unifying optics with electromagnetism. At the beginning of the 20th century, Einstein unified time and space, and at the dawn of the 21st century, physicists are doing their utmost to unify the four fundamental natural forces into one superforce. The physical laws that describe the universe tend toward unity. I, therefore, have a hard time with the idea that this profound unity is the result of pure chance. Matthew. The fact that the universe and our own existence might have evolved simply according to the laws of causality, without the intention of a creator driving the process, would not exclude the possibility that the universe displays harmony, and also wouldn't imply that, as Jacques Monod, excuse me this morning, it also wouldn't imply that, as Jacques Monod wrote, man is lost amidst the feeling of immensity. Try again. Sorry, Jacques. Maybe it will help to read it in a French accent, you know. Man is lost amidst the unfeeling immensity of the universe, where he has arrived by pure chance. Or that the universe is meaningless. We can find a great deal of meaning in the way our world is. The interdependence of the world and our consciousness allows us to use that consciousness to attain knowledge, which gives a very definite meaning to the whole setup. Swan. I should clarify that I don't think the ultimate purpose or meaning of the universe is human life. Life surely hasn't finished its ascension toward complexity. The universe will continue to evolve, and humankind with it. My point is that I have problems with the idea that this cosmic evolution leading to human life came about purely through a series of wonderful coincidences, of lucky rolls of the dice that would easily never have happened. I should be clear that I have no problem with the existence of the kind of chance that Jacques Monod lamented. When a biochemist like him talked about chance, he meant the chance encounters between quarks in order to form the nuclei of atoms, between atoms at the center of the stars in order to feed their fires, between the atoms created by stellar combustion in order to form interstellar molecules and planets, and between organic molecules in the primordial oceans in the form of interwoven helices of DNA. I have no doubt that these processes are in a fundamental way ruled by chance, revealed by quantum theory. In this sense, I can agree that the contingency plays an important role in the evolution of the universe. I certainly do not subscribe to Laplace's view of a completely deterministic universe. It would be absurd to say that the first moments of the universe totally determine the fact that we are now here talking. Rather, I think that as soon as the laws of physics were fixed, they formed a cloth that was ideally suited for nature to embroider. Oh, that's pretty. The manner in which that embroidery proceeds is one largely driven by chance. Quantum fluctuations in the world of atoms, chaotic phenomena in the macroscopic world, such as those that are responsible for the weather, as well as the accidental contingent events, such as the asteroid that hit the Earth 65 million years ago and killed the dinosaurs, thus allowing the emergence of mammals, and subsequently human beings, have all freed nature from its deterministic straitjacket. Nature has evolved to be the inventor of complexity. Just as a jazz musician embroiders around a theme, thus improvising new melodic phrases according to his inspiration and the public's reactions, nature plays spontaneously with the physical laws that were fixed at the start of the universe. I like that idea. This is like my new favorite paragraph in here. It uses them to create novelty. But I cannot accept that the choice of physical constants in the initial conditions were matters purely of chance. As soon as the constants and the initial conditions were fixed, matter already contained the seeds of consciousness. A cosmic gestation started leading inexorably toward us. In the end, if we reject chance and the idea of multiple universes, and if we postulate that the existence of just one universe, ours, then it seems to me that, like Pascal, we must wager on the existence of creative principle. We must wager on the existence of a creative principle. Matthew, very well. Let's now examine this principle. First, in your view, does it imply a will to create? Swan, my view is that the constants and initial conditions were intentionally fixed so that they led to a universe that was conscious of itself. It's not up to you if you want to call it, it is up to you. It's up to you if you want to call the cause of this selection God or not. I do not personally believe in a my God. Gonna take a second. Try again from the top that little bit. My view is that the constants and initial conditions were intentionally fixed so that they led to a universe that was conscious of itself. It's up to you if you want to call the cause of this selection God or not. I do not personally believe in a personified God, but rather in a pantheistic principle that is omnipresent in nature. It's a little bit more, I've been leaning that way too, a little bit more like the ancient Greeks had the, what are they called, like the elements, but they were like beauty and love, so they weren't quite elements. That's sort of my thought of what God is. Pantheistic principle that is omnipotent in nature. There we go. This is somewhat akin to the views of Einstein and Spinoza. Einstein described it as follows. The scientist is a... My quotes are shit today, sorry. The scientist is possessed by the sense of universal causation. His religious feeling takes the form of a rapturous amazement at the harmony of natural law, which reveals an intelligence of such superiority that, compared with it, all the systematic thinking and acting of human beings is an utterly insignificant reflection. I don't know why that's what Einstein sounds like, but it's because my Austrian accent is... We're not doing that. He added, I believe in Spinoza's God, who reveals himself in the harmony of all that exists, but not in a God who concerns himself with the fate and actions of human beings. I like that. I like that too. I kind of like realizing that we're not, like, super important. Modern science has, in fact, provided a good deal of evidence against several of the arguments that Western philosophers and theologians have used to prove the existence of a classic God. One of these arguments in proof of God is what I'll call the complexity argument, which states that only a creator could have produced such a complex, structured universe. A watch has to be made by a watchmaker. It can't assemble itself. You can't write a book just by throwing an inkpot, a pen, and some sheets of paper onto a table. I've tried. But contemporary science has shown that a highly complex system can in fact result from a perfectly natural evolution based on known physical and biological laws, and there is no need to call in a watchmaker God. Then there is the cosmological argument, which was used by Plato, Aristotle, St. Thomas Aquinas, and Kant. This argument states that everything has a cause, but there can't be an infinite chain of causes. The chain must necessarily begin with a prime cause, and they argued that the prime cause was God. Quantum mechanics has raised doubts about the premise that everything has a cause. Thanks to his famous uncertainty principle, Werner Heisenberg showed in 1927 that uncertainty is an inherent part of the subatomic world and that particles can materialize in unpredictable ways, without the slightest need for any cause. Just like any particle, the universe can, in principle, spring up from a vacuum without any prime cause, thanks to quantum fluctuation. Matthew, why shouldn't a chain of causes be infinite in time and complexity? What law of nature does that contradict? How many causes must we have before saying, that's enough, I can't keep going back in time ad infinitum, so let's adopt a causeless creator. Swan. Yes, of course, the cosmological argument does depend on a linear concept of time. Other philosophers have suggested that time is circular, thus eliminating a need for a prime cause. So instead of there being a linear progression in which A happens, which causes B, which leads to C, and so on, we would have a cyclical progression in which A causes B, which leads to C, which in turn is responsible for A. The snake bites its own tail, and the cycle is closed. There's no more need for a prime cause. Matthew, another odd idea. Oh, that was more excited. Another odd idea. I was probably too excited. Like the prime cause, the idea of a closed circle is just an escape route for people who can't bear the idea of infinity. When you say that a particle materializes without any cause, you're limiting causality to a simple logic of A producing B. But if, through interdependence, B results from the existence of the entire universe, from an infinite number of causes and fluctuating relationships, we can't say that it occurred spontaneously just because we are incapable of identifying a particular cause. Swan. Another scientific argument against the existence of God is that the very idea of cause and effect loses its meaning when applied to the universe. This notion presupposes the existence of time so that cause reliably precedes effect. But according to the Big Bang, time and space appeared simultaneously with the universe. If time didn't exist before this, then what does God created the universe mean? The act of creating the universe is meaningful only in time. Is God in time or outside of it? Time isn't absolute, as Einstein said. It's elastic and is stretched or contracted by accelerating motions or fields of intense gravity, such as those around black holes. A God contained in time would no longer be all-powerful because he would be subject to the laws of time. A God outside time would be omnipotent, but unable to help us, since our actions happen in time. If God transcended time, then he would already know the future. If he knew everything in advance, why would he bother to become involved in the struggle of humankind against evil? Matthew. God must be either immutable and thus unable to create, or else inside time and thus not immutable. This is one of the contradictions the notion of a prime cause leads to. What are the justifications behind this argument? First, if there is a prime cause, it should be immutable. Why? Because by definition, it has no other cause than itself, so it has no other reason to become different. Change would imply the invention of another cause that wasn't part of the prime cause. Second, how could an immutable entity create something? If there is an act of creation, is the creator involved or not? If he is not, why call him creator? If he is involved, then because creation inevitably occurs in stages, the something or someone involved in these stages is not immutable. One could agree with St. Augustine that God created time and the universe, St. Augustine being one of my favorite cities in the whole world. But even so, creation remains a process, and any process, whether temporal or not, is incompatible with immutability. This point did not escape St. Augustine himself, who said that the notion of beginning involves an act of faith. Buddhism contends, by contrast, that such an act of faith is unnecessary, provided one doesn't cling to the position that there must have been a beginning. Swan. So there are many compelling arguments against the existence of a God. But the principle of organization that I believe is quite different from classic God. What I'm talking about is a principle that finely tuned the universe at the beginning, and not a personified God. Matthew. But if you want to talk about a principle of organization, you can't be so vague about it. We must be able to discuss it. Swan. These questions have endlessly bothered theologians and philosophers of all persuasions, and I certainly don't claim to have the answers. I am engaged here in a metaphysical wager. Science has no special authority about this subject. Matthew. But we can't postulate the existence of something and at the same time have nothing to say about it. If the principle of organization has no characteristics, then why doesn't it matter? If the principle of organization has no characteristics, then it doesn't matter whether it exists or not. We can eliminate it with Occam's razor. Was this principle born of itself? Was it caused by something? Is it permanent, omnipotent? To which whoever owned this book before me bracketed this, oh my, and said, nope, where did he say that? Right here by my finger. He said, yes. Swan. Omnipotence, omniscience, and so on are the qualities of a god. And it's true that we tend to identify this principle of creation with a creator god. Physicists don't talk about God, however. Rather, they refer to physical laws. The properties of those laws are strangely reminiscent of how God is generally described, and this leads many people to see a relationship between them. The physical laws are, for example, universal and applied everywhere in space and time, from the teeniest atom to the largest galaxy. They're absolute, since they don't depend on the person that discovers them. The fact that discoveries are often made by individuals does not mean that the individuals have created the truths they find. The truths are there to be found. The physical laws are also timeless, because even though they describe a world governed by time and constantly changing phenomena, they themselves never change. We live in a temporal universe ruled by atemporal laws. The laws are omnipotent because they apply to everything everywhere. Finally, they're omniscient because they act on material objects without having to be informed of the particular states of these objects. Omniscience. Omniscience. They know in advance and legislate just the right instructions to command the behavior appropriate to those states. And so the characteristics of physical laws are the same as God's. Matthew. I still don't see why these laws should point to the existence of a creative or organizing principle. They quite simply reflect the interdependent nature of phenomena. Swan. I agree that the idea of interdependence could explain the fine-tuning of the physical laws and initial conditions that allowed life and consciousness to come about. But I don't see how interdependence answers Leibniz's existential question. Apparently, reading for almost an hour gets exhausting, but I've only got a couple pages, some more to go. Okay. I don't see how interdependence answers Leibniz's existential question. Why is there something rather than nothing? Matthew. But postulating the existence of a principle of organization doesn't answer this question either. Why was there a principle of organization rather than nothing? And what do we mean by principle of organization? Is this principle some kind of an entity, some kind of a consciousness that conceived a functional model of the universe? Did the principle decide what it wanted to create? Does it have intention? Swan. I believe the answer is yes. The principle of organization wanted to create a conscious, intelligent observer. I believe this is why our universe was set up to evolve in the manner that it has. Matthew. But if the principle did decide to create, we must recognize that it cannot be all-powerful because it was influenced by the desire to create. If you then argue the other way and say that the principle did not actually decide to create, then you must concede that the principle is not all-powerful because it created within deciding to create. Therefore, it wasn't free to create or not. The principle also cannot be timeless, or immutable, because, as we have seen, in the process of creating it will necessarily have itself changed. It went from having the desire to create to having done so, and therefore it would no longer have the desire in the same way. Creation implies change. There is a creative act. After creating, the principle would no longer be the same. Before it wasn't a creator, and after it was. The principle has thereby lost its immutability. Another troubling question about this principle is whether or not it was born without a cause, or whether it was perhaps its own cause. Swan. I think it was its own cause, but once again, we are stepping out of the domain of science here, and this is just a matter of my beliefs. We're so almost done. Matthew. If the principle was its own cause, then once again, Buddhism would argue that it must be immutable. An entity that exists because of itself has no reason to change. Only things produced by something else can change. So we run into another contradiction, because if the principle is immutable, then it can't create. Buddhism argues that if something permanent can't produce something something ephemeral. What's more, as said above, if it creates, then it is no longer immutable, since creation implies change. Any creator must in turn be modified by its creation, because each action implies interaction. No cause can be one way. Causality is necessarily reciprocal. Any creator is acted upon by its creation. Another very important point is that if something has no cause other than itself, the concept of interdependence says that it is then prohibited from interacting with other things. Buddhism does not believe that anything can be the cause of itself. Swan. So each event or entity must have a cause. Doesn't that lead to an infinite regression? Matthew. Such a form of infinity definitely goes against traditional. Western metaphysical, that is all one-sided. Such a form of infinity definitely goes against traditional Western metaphysical belief. Both the religious and scientific viewpoints have insisted that there must be an ultimate beginning. As the philosopher Bertrand Russell wrote, there is no reason to suppose that the world has a beginning at all. The idea that things must have a beginning is due to the poverty of our imagination. This desire to find a beginning comes from the idea that everything has the real solid existence that our minds generally perceive. Swan. And yet, as I explained earlier, quantum mechanics does provide a way around this need for an ultimate beginning. A beginning is no longer really necessary. Matthew. If a beginning is no longer necessary, and there I'm in complete agreement, then neither is a principle of organization. How could it have organized phenomena that have no beginning? All it could do would be to modify how they evolve. Another argument against this principle of organization is that if it organized the entire world of phenomena, then it must contain all of the causes of that world. Otherwise, something would exist that was outside its creation. Swan. That's logical. Matthew. But the law of causality says that if an event doesn't take place, then it's because certain causes or conditions were missing. If a seed doesn't germinate, then it must be defective, or else lack water, heat, and so on. An effect can't occur until all the necessary causes and conditions have come together. On the other hand, when they are all present, then the effect must necessarily occur. If it doesn't happen, then something must still be missing. If so, this principle of creation contained all of the universe's causes and conditions. It must constantly create the entire universe. It would be something like a permanent Big Bang. Swan, you mean that it couldn't stop? Matthew, that's right. If it did stop, then this would mean that it no longer contained all of the causes and conditions of creation. We would then need help, either from another principle upon which it was dependent because this second principle had some of the causes, or else from a regulating principle that checked its creation. Either way, it would lose its omnipotence. So there are just two possibilities. Either it doesn't contain all the causes and conditions and so cannot create, or it does have them all and so creates continuously. Swan, which is also absurd. Matthew. Some people counter this objection by saying that the creator would create the world progressively. That, too, would imply that the universe had multiple causes and that the creator didn't possess all of the causes at the beginning of the process. So where did it subsequently get them from? Others claim that the act of creation is atemporal and that the world is being created now just as much as it has been and will be created. This is to see creation as a series of events that are simultaneous from the creator's viewpoint. But this position doesn't escape the problem of a principle that must contain all the causes of the universe and so continually create the entire universe. What's more, if all the universe's past, present, and future events were simultaneous so far as the Creator was concerned, then this would lead to absolute determinism. It would mean that any attempt at personal transformation in order to dissipate ignorance and reach enlightenment would also be in vain. On the other hand, absolute determinism can be avoided by the play of interdependent relationships without beginning or end, because the causes and conditions of the relationships are unlimited and so can't be reduced to a single primordial cause. One final argument against the whole notion of beginning or creation is that if the Creator possessed not only all the causes, but also all the effects, then we could hardly talk about creation anymore, since everything was already there. Some Hindu philosophers have said that the Creator becomes the matching cause for each step in the creation while still remaining immutable, as a dancer can perform different choreographies in different costumes and still remain the same person. But that contradicts the idea that the Creator is the sole cause of the universe. A single cause can't lead to diverse effects. What's more, a unity with changing aspects that can neither be a true unity nor immutable can neither be true unity or immutable. If the effect is intermittent, then the cause can't be eternal. To sum up the Buddhist alternative way of thinking, which requires no principle of organization, in the Buddhist world of appearances, each instant is a perpetual end and beginning because of the lack of impermanence of the phenomena produced by the laws of cause and effect. In the terms of absolute truth, all past, present, and future events are identical in that they have no intrinsic existence. Thus, they have no real end or beginning. If nothing is really produced, there is no need to look for an end. And so, it isn't necessary to search for a principle of organization that is supposed to have made everything. I think I got lost in that sentence. And so, it isn't necessary to search for a principle of organization that is supposed to have made everything and have been made only by itself. Swan. So, flying in the face of monotheistic religions, Buddhism categorically denies the existence of God the Creator. Doesn't that sit uneasily with the image of tolerance that Buddhism usually likes to project? How do you reconcile this position with respect for other beliefs? Matthew. No matter how tolerant you are, you don't have to accept other people's metaphysical viewpoints, but you must respect the means of personal transformation that suits best other people's natures and predispositions. Also, there are many ways to think about God. To quote the Dalai Lama, there seems to be a way of looking at God not so much in terms of a personal deity, but rather as a ground of being. Yet qualities such as compassion can also be attributed to that divine ground of being. Now, if we are to understand God in such terms, as an ultimate ground of being, then it becomes possible to draw parallels with certain elements in Buddhist thought and practice. But neither should we make an amalgam of all the forms of religions, spirituality, science, humanism, or agnosticism. That isn't the aim of tolerance. The Dalai Lama went on, I do not personally advocate seeking a universal religion. I don't think it is advisable to do so. And if we proceed too far in drawing these parallels by ignoring the differences, we might end up doing exactly that. Metaphysical positions must be clearly expressed. There is no reason to be ambiguous about them. If they're wrong, then let's prove it. Buddhism is quite prepared to admit its own mistakes, if they can be proven to do so. It's quite prepared to admit its own mistakes, if they can be proven to be so. Intolerance consists in being so sure of the truth that you want to impose it on everyone else by persuasion or even by force. We must have an open mind to realize that what suits us doesn't necessarily suit others. One cannot eat a particular food and then say, because it is nutritious for me, everyone must eat it. Each person must eat foods that are suitable for the best physical health according to his or her own physical constitution. As regards to spiritual practice, belief in God can give some people a feeling of closeness with their Creator and encourage them to become more loving and altruistic in order to express their thankfulness and participate in the love of God for living creatures. For others, a deep understanding of interdependence and the laws of cause and effect, linked with a desire to reach enlightenment in order to help all sentient beings, are greater sources of inspiration in the development of love and compassion. To conclude, when embarking upon a spiritual path, it is important that you engage in a practice that is most suited to your mental development, your disposition, and your spiritual inclinations. Through this, one can bring about inner transformation, the inner tranquility that will make that individual's spirituality mature and a warm-hearted, whole, and good and kind person. That is the consideration one must use in seeking spiritual nourishment. I like that. That was a very nice chapter. Thank you, guys.